We have supersonic jets, formula racing cars, and satellites that circle the Earth in the blink of an eye. But in this world, railways seem to be obsolete. And then a bold idea was born. Put jet engines on trains. It may sound like a joke, but this is one of the most interesting and strange chapters in the history of modern transportation. This is the story of the jet train, a dream of speed that once amazed the world. In the mid-20th century, the United States was at the height of its development. Commercial aircraft were booming, automobiles were becoming more popular, and interstate highways were stretching across the country. Meanwhile, passenger rail was in freefall. Slow, outdated trains were no longer attracting passengers like they once did. Engineers and railroad companies knew that if they didn't change, they would be left behind. But how could rail be compared to planes or automobiles? The answer: learn from the planes themselves. Put jet engines on trains. It wasn't just a strange idea, it was actually put to serious testing. Trains powered by engines taken from fighter jets were hurtling down the tracks at unprecedented speeds. The dream of a supersonic train seemed to be coming true. New York Central's M497 jet train. In 1966, New York Central Railroad unveiled an ambitious project, the M497 Black Beetle, a train powered by two jet engines taken from a B-36 Peacemaker fighter plane. The train was aerodynamically designed, with an aluminum and glass nose that resembled an arrowhead, to reduce air resistance. The two jet engines mounted on the roof of the train generated enormous thrust. The train was tested on a straight stretch of track in Ohio, where there were no regular freight trains, making it an ideal place to test its speed. The result? On July 23, 1966, the M497 reached a speed of 295 kilometers per hour, an unprecedented speed for a train in the United States at the time. People were amazed. The press reported it widely. A glimmer of hope. Had the American railroads found a way out? However, after that spectacular test, the M497 was shelved. How could such an impressive idea be forgotten so quickly? The test was successful, but the jet train never entered mass production. The main problem with the jet train is that the jet engine was born for the sky, far from homes and people. But when it came to the ground, things were different. The sound of a jet engine was almost unbearable for the surrounding residents. Running through urban areas, almost impossible. Not only was the noise annoying, it also violated many environmental and public health regulations. For the jet train to become a reality, it needed an operating corridor far from residential areas, something that was almost impossible to do on a large scale. The jet train needed to operate on high quality, straight tracks with few curves and no obstacles such as road crossings. But the U.S. rail infrastructure of the time was not built to handle high-speed trains. To make the jet train operate safely, it would have required the rebuilding of virtually the entire rail network, a huge investment that no one was willing to pay for. The jet train needed to operate on high-quality, straight tracks with few curves and no obstacles, such as road crossings. But the U.S. rail infrastructure of the time was not built to handle high-speed trains. To make the jet train operate safely would have required the rebuilding of virtually the entire rail network, a huge investment that no one was willing to pay for. The jet train also faced technical challenges. Traditional trains use braking systems that rely on friction between the wheels and the rails, but with the jet train, the speed was so great that mechanical brakes became unsafe. At that time, air brakes and electronic braking systems were still in their infancy. High speeds without good stopping control? This is a recipe for a catastrophic accident. Moreover, jet engines consume a lot of fuel. This is acceptable on airplanes, but not suitable for the operating costs of trains. The jet train was both fuel-consuming and required complex jet engine maintenance, which made the total cost skyrocket. When compared to modern airplanes or trains, jet trains are fast, but not economical, not flexible, and not environmentally friendly. Jet train, not just an American dream, although the M497 project in the U.S. is the most well-known. The U.S. is not the only country that has pursued the idea of jet train. All over the world, from the Soviet Union to France, many countries have dreamed of jet trains. In the 1970s, the Soviet Union built an experimental jet train model called SVL, equipped with 2 engines from Yak-40 aircraft. The test train reached speeds of up to 250 kilometers per hour. It's quite impressive compared to the infrastructure at that time. However, like the US, the Soviet Union quickly realized the same problems. High cost, loud noise, difficult to control. SVL was also quickly abandoned, and the Soviet Union switched to investing in more traditional electric train systems. France did not pursue jet trains, but they learned from the jet train to develop the TGV system, a high-speed electric train. Instead of using jet engines, TGV uses electric motors that drive the wheels directly, combined with high-quality rails. Thanks to that, France not only avoids the noise problem, but also can control the speed, save energy, and ensure maximum safety. TGV proves that, to achieve high speed on land, the solution does not lie in jets, but in electricity and comprehensive system optimization. General Electric and jet train, the last resurgence. It seemed like the idea of jet trains had been forgotten, but in the early 2000s, General Electric decided to try again. But this time, they did not use jet engines, but kept the same name, Jetran. GE Jetran is a combination of a gas turbine engine, the same engine used in helicopters, and a traditional train chassis. The biggest advantages: light, strong, and not dependent on electrification of the rails. GA promotes jet train as an ideal solution for countries with any electrified rail infrastructure, but still want to develop high-speed trains. Instead of investing billions of dollars to install power lines and transformer stations, countries can use jet train, as long as the rails are of good enough quality. The train is designed to reach speeds of 240 to 260 kilometers per hour, with comfortable modern passenger compartments, less vibration, and much smoother operation than previous generations of diesel trains. Why did GE's jet train fail? Though the jet train was demonstrated to Canadian, American, and Asian officials, it never went into commercial operation. There were many reasons for its failure. The market wasn't ready, and developing countries didn't have the money to upgrade their tracks to meet standards. Developed countries opted for electrification, a more environmentally friendly and long-term solution. Gas turbines were still not economical, and although they were light and powerful, they consumed much more fuel than electricity. When oil prices fluctuated, the economic efficiency of the jet train was severely affected. The high-speed train market was dominated by electric models such as the TGV ICE and Shinkansen, which were more stable, safe, reliable, and economical than the jet train. GE eventually stopped promoting the jet train, and the prototype was put in a museum. Once again, the jet train dream was forgotten. Does the jet train still have a chance? So the question is, can the jet train idea, or at least its spirit, be revived in the future? The answer is not necessarily no. Today, technology has come a long way since the 1960s. New generation jet engines are quieter, more efficient, and more environmentally friendly. Autonomous control technology, artificial intelligence, and advanced sensors help modern trains brake safely at high speeds. Yet, lightweight materials, aerodynamic frames, and superior soundproofing enhance the passenger experience. In theory, a jet train 2.0 could leverage new technologies to address old shortcomings. While not feasible in dense urban areas, the jet train, or other high-speed variants, could be useful in sparsely populated areas where flying is inconvenient and rail systems are underdeveloped. Deserts or vast rural areas such as Australia, Central Asia, the American West. Dedicated high-speed freight lines that bypass residential areas. High-speed travel corridors between remote resorts. In these places, the jet train is not constrained by noise or complex environments. Speed becomes a major advantage. Another way to look at it is the jet train has fulfilled its historic mission. Although it was not a commercial success, it serves as a mobile technology laboratory, helping the world better understand the limits of rail speed, the right approach to building a high-speed rail network. Lessons for long-term infrastructure investment. Thanks to the jet train and its failures, the world can choose a more rational, more efficient path, like the TGV, the Shinkansen, or the magnetic levitation trains of the future. Jet trains may be a short chapter in history, and we don't need a jet.